Hey guys, welcome back to Python. In this course, we're going to be working with loops. And so this is a nice way to do repetitive actions without having to type the same line of code over and over and over and over again. For instance, I used to, because I was lazy and didn't want to screw up a loop and I was intimidated, for my research, I take pictures of plants growing. I know it's riveting, but we take pictures of how plants develop, and so we take them at certain time points, like every half hour or something like that. So instead of writing a line of code that says take a picture at 0 minutes, take a picture at 30 minutes, take a picture at 60 minutes, take a picture at 90 minutes, etc., we can write a loop that says every 30 minutes, take a picture. It saves you a ton of writing of code and mistakes, and you can have it run indefinitely. So it is a very nice skill to have to write loops. So without talking too much, let's go ahead and jump right into our loops. Okay, if you're on Praxis, first things first, desktop, classroom, my files, then create your Python notebook here. All right, then you can save it as whatever you want. Actually, you shouldn't save it as, well, you can save it as whatever you want because you're going to be doing a final project, but we're going to call it loops. So if you need, so for those of you taking this as my class, save it as something that makes sense so that if I have to go look for it to help you because I can access all your files, I can find it, right? If it's untitled 10, I'm not going to go through all your untitles to find the stuff to help you. So let's see here. So first things first, we're going to do some odds stuff here. All right, so we're going to say odds equals 1, 3, 5, and 7. Run that. And then we can, because we have these stored in a list, we can say print odds 0, which would be our first entry, print odds 1, print odds 2, print odds 3. And if we run those, you can see we print them down in, oops, scroll down, in order. So the one thing that stinks about this, so this is, let me take a step back. So say you have a list of things and you want to print them one by one, okay? This is where the loops come in, right? So as you can see, I can do this where I type a line for each entry in the list. It's a bad approach for a few reasons. First, it's not scalable. So imagine that our list was 100 elements and you had to write 100 lines of code to print each one one by one. It's hard to maintain, so if you want to decorate each printed element with an asterisk or any other character, you would have to change all 4 lines of code. But in this case, 4 lines of code because we only did 4. But if you say you finally wrote your 100 lines of code to print out 100 elements from your list, and then you're like, oh crap, I forgot, I need to add a decimal. So you have to go back and format 100 more lines of code or rewrite, right? That's not good. And the last thing is it's fragile. If we use it in a list that has more elements than we initially envisioned, it will only display part of the list's elements. So a shorter list, on the other hand, will cause an error because it'll try to display elements of that list that do not exist, right? So if you're not perfect with matching your number of lines of codes with the number of elements in the list, then you're going to have errors thrown. For example, if we do odds equals 1, 3, 5, and then we did print odds 0, print odds 1, print odds 2, oops, and then print odds 3, and say we got confused because Python's weird, remember, and it makes the first element 0. Then we get this error, right? So that's an example of if we try to print more than we're actually in our list. So what we can do instead is we can make a loop. So we do odds equals, we'll make our 1, 3, 5, 7. Then we can write this loop. This is for num in odds, which stands for every number in odds, which we've said, print the number. If we run this, boom, look at that. 3 lines of code instead of 5, but say we made this longer, right? So we say 7, 9, we'll do all the 11, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Say we did that. Look at that. We didn't have to write any more lines of code and it printed everything. Beautiful. This improved version that we wrote uses a for loop, so for, to repeat an operation, in this case printing, once for each thing in the sequence, right? So generally, you get this, right? This is kind of what it's doing. So we have our odds 1, 3, 5, 7, 9, 11, and stop there. For every number in odds, and so it shows odds here as 1, 3, 5, 7, 9, 11. So every time there's a number in odds, print what that number is. So we'll print 1, we'll print 3, print 5, print 7, print 9, print 11. So it has 6 times through the loop. We're each number in the variable odds is looped through and printed one number after another. The other number in the diagram denotes which loop cycle the number went through. So that's what these are, right? So loop cycle 1, loop cycle 2, 3, 4, 5, and 6 prints. It goes through each number. So it's cool. It's a very quick way to print things or to do something, shorten something that would be a lot of code. All right, so let's do another loop quick. So length. This is a important one if you're gonna write fancy stuff. So length equals 0, names equals Curie, Darwin, Turing. So for value in names, length equals length plus 1. And we go and print, there are length names in the list. Okay. So if you run this, it counts for us, right? So it says, okay, every time you go to a value in the list, add a number to length. And we started length at 0. So it goes, okay, we're going to go through the list once, and we see Curie as a name. So length becomes 1. The next time through the list, we see another name, and we're like, oh, okay, so I'll add that to length, which was just changed to 1 for Curie, and now is 2. Go through this again, we find Turing, add that to length, which is 2 because of Darwin, and that becomes 3. And then there's no more. So then it prints, there are 3 names in the list. So this is important. So a lot of times when you're counting iterations or you're counting things, this is how you would do it. So if you wanted to count the number of base pairs, if you want to count the number of, all my examples are going to be biology, codons or proteins or amino acids or anything like that. You can do it with this type of iteration loop. So note with this though that a loop is variable, and a variable is being used to record progress in a loop. It still exists after the loop is over, and we can reuse variables previously defined as loop variables as well. So for example, if we did name equals Rosalind, and then we did for name in Curie, Darwin, Turing, print name, and then print after the loop name is name. Okay. So, as you can see, we started with our name is Rosalind, right? And then we used name in this loop. For name in this list, print name. And so that writes over what the name previously was. So we had name stored as Rosalind, and then we said for name in this, so we're saying save this as a variable, name, Curie, Darwin, Turing, print name, and then print name after the loop, just to show that it does save over. So it says, and it saves it as the last variable in your list, so Turing. So now, this is important to note when you're writing loops, to not reuse a variable name from earlier in your script, because it could cause you to write over that variable and you mess up your script because of it. Okay, so we wrote a length script, right? So we said, okay, count these things, and there are 3 names in the list. Well, this is a very common operation, right? You can imagine that it is used somewhat often. So there's actually a built-in function that Python did for us to make it so you don't have to write those loops over and over again. So you can say print length, and then of your whatever your vector is. So here we say 4. So if we did name equals Curie, let's do this, Darwin, and Turing, there we go. And then we said print len name, and did this. You can see it prints out 3, right? So there are a lot of times where there are common functions that we use a lot that are important that Python realized, or the writers of Python, developers of Python realized, and so they built things in like length. But it's nice to kind of see the underpinnings of how that loop works. So essentially that's just kind of like a saved function that we wrote the real function for underneath, but it's just shortened to len, which is nice because it's a lot less to write. So that is it for loops. A short one. Look at that. 15 minutes-ish, minus intros and exits and all that stuff. I hope you liked the video. I hope you understood loops a little bit. Please hit like, please hit subscribe if you're watching on YouTube. I hope you're enjoying the content. Let me know in the comments, and I will catch you in the next one.